Right, hi there, guys. Today we're now going to move on. So, spent a couple of days making sure we were absolutely happy with the converse of Pythagoras, and we were completely okay when it came to surds as well. So, we're now going to see, as you can see from the screen, we're going to look at Pythagoras in three dimensions. So far, most of the work we have done, we've only ever considered the two dimensions, the x and the y part of the grid. Hopefully, you see the highlighting them right now. So when we add a third dimension, we give this third dimension the name of the Z or the Z axis, and we imagine it coming out of the page. So as it comes out of the page, it goes positive, and just like X and Y, as it's one negative, which of course is downwards. But for the time being, we're just going to purely focus on everything on the positive side of the coordinate plot. So in this area here. The most common shape that we look at initially in 3D Pythagoras is the cube and the cuboid, just the easiest ones to work out. So before we go into that, we've got to give ourselves some terminology we work with. So as we've seen before, we've seen a cuboid before, we see this in volume. But we have proper names for everything in the cuboid because we have faces, we have edges, and vertices. The two main ones we'll use are faces and vertices. Firstly, what is a face? Well, the face is the side of. Oh, this is appearing right there. Don't know why that happens. Face is the side of the shape. So these bit here. So the bits you can see, that's a face. The one in grey in the very front's a face, and yellow is a face, and brown is a face, and of course we have three more faces at the back that you just cannot see. So the faces are the bit that you can see of the shape. That's the face. The vertices are the lines where they meet, or the points of the meet. So a vertex is the point that two lines meet, or three lines, I should actually have said, where three lines all meet, and that's in the corners of your shape. In the case of that one, it has 8 vertices. And finally, the basic terminology are edges, and edges are where two faces meet, or the lines. So lines are created when two faces meet together. But we don't tend to use that one. The ones we tend to focus on are the ones you'll see the most in 3D Pythagoras are faces and vertices. So first one, in terms of faces, we have a face diagonal. A diagonal joining the two opposite ends of any rectangular face of a cuboid. So there's a line that goes right across the face. You'll see one of them in a minute. A space diagonal one that goes from end to end of the shape right through the middle of it, or where the space would be. Of course, pause this at any time to copy some of it down. So let's look at an example. First one, E to EB, goes right across that front face, which is called EFBA or ABFE, whatever you want to call it. That is the front face. The diagonal is being drawn right across it, just like it was a normal bit of paper. We then have the space diagonal, AG, which goes right across the shape. So it goes right across from end to end. And it's these kind of information we're going to use to allow us to solve problems within these cuboids and cubes. So let's look at how we do it and what we would do. So here's our example. We want to calculate the space diagonal. I want to know how long A to G is. I've been told the dimensions of the cuboid is a 10 by 6 by 8. So I have those dimensions, but none of them allow me in one simple motion right now to find the length of AG. So we're going to split this problem into two parts. So in part one, we find the face diagonal AC. So we find this diagonal here by creating a right angle triangle. There's the face diagonal AC on the bottom. Why did I choose that one? Because it's going to allow me to create a link to the space diagonal AG. It'll create another right angle triangle, but let's focus here first. So step one, we use the two measurements that we have. We have the length and the breadth of the bottom of the rectangle, so we can create that. So we use standard Pythagoras. We want to find the longest side. Should I put that in first? So c squared is equal to a squared plus b squared. This time let's put the letters in. I want to find AC squared, so it's 6 plus 10, 136. So AC must be the square root of 136. If it's non-calculator, of course, you would give me that answer in a simplified third. This is calculator work. So I find out the square root of 136 is 11.7 centimetres. So that's my step one. I find the length of the face diagonal. In most cases, it's always when I start, I find the length of a face diagonal will help me find the space diagonal. So now that I've done that, what I then do for part two, there's all the information I have. I know all this information here. I then use that to create another right angle triangle, which you should see appearing there in green. So using the value I've just calculated, that's why I chose that one. I now have a new right angle triangle where I know a base and I know another length that allow me to find the longest side. So once again, this is going to be one of those ones which is, I'll get this up a bit because I've kind of squeezed it down. It's going to be using this here. So give me a second to move some of my details down a bit so you see what's happening. Whoa, there we go. That's the back. So we're going to find the longest side again. So we plug those numbers in. 11.7 squared plus 8 squared. There we go. 200.89. And it goes through to give me my final answer of 14.17, which is this bit here. That is my space diagonal. So the length of space diagonal is 14.17. So just to recap, in a cuboid or a cube, when calculating a space diagonal, which is a line that goes from end to end right through the shape, we're going to be doing Pythagoras twice. That's principle what it is. The first Pythagoras is based on a face diagonal. I forgot what I was going to say there. But this one here, jump back a bit. So once I've done that, I've got that answer for that line there. I'm then going to create a new right angle triangle with the space diagonal. So there we go. And that's where I got that one there for the second part. So it's just Pythagoras twice. Have a go at the first few questions on the exercise. I'd like you to try questions 1 through to 4 on the attached exercise, guys. I'm then going to put a second video I'd like you to watch where we talk about pyramids and how we would use Pythagoras within that. Good luck.